So this week, yesterday, you read chapter 19, sections 1 and 2. Today we're going to do a few notes for section 1, which was on seasons. And tomorrow we'll do a flip lesson for section 2, which was on gravity and motion. So first of all, let's look at a few of the vocab words. First of all, the first word was axis, which is, I think you guys know that. And then the next two words are rotation and revolution. And here are the actual definitions, but we're going to do a little demonstration to help you understand them better, get them straight. But basically, rotation is when a body turns on its axis, and in terms of the sun, earth, moon, this motion causes day and night. Revolution is when an object moves around another object, and this is what causes the years, and an orbit is the path around of one object around another. So let's take a look at doing this kind of hands-on. So with your earth on the stick, you can demonstrate rotation on an axis, and you can demonstrate revolution. Your head is the sun, and the styrofoam ball is the earth. And so you can do this. So rotation and revolution will be pretty straightforward here. Then astronomy was one of our words. The astronomy is the study of the sun, moon, and objects in space, which is what we're studying all quarter. We're going to come back to seasons here in a second. Let's actually jump to this. So what we want to do, what causes the seasons is, of course, the tilt of the earth. So as you hold your styrofoam ball, if you hold it so your eyes are directly at the equator, then your head is the sun. As you stare at the earth, your eyes are beaming out sunlight, and that is causing day and night. And if you are looking directly at the equator, then this is going to be spring or fall. Now, if you tilt your earth so that the North Pole points at the front board, you're going to be like this, North Pole at the front board. What season is it in the northern hemisphere? Okay, so by using your head as the sun and the styrofoam ball as the earth, you should be able to demonstrate this. In a minute, the lab we're going to do today, you actually get light bulbs and earths to do the same thing. But the way we test you on this, on the quiz, on the unit test, probably on the standardized testing you'll take, you always have to label a diagram because it's hard to test people in person. So if you look at a diagram like this, you always have the sun in the middle, of course, and you see the tilt of the earth. In a diagram like this, the summer and winter will always be on the left and the right. Now, how do you know which one is the summer? Well, you look where the sun's rays are pointing. So is the summer in this picture, is the summer on the left or on the right? It's on the left, right? Well, partly because it says summer solstice. But if you look at, these are the sun's rays. Here's the equator. Here's the North Pole. And so if you look at this, if you drew a line for day and night, the day and night line goes like this. South Pole is in 24 hours of dark, and the North Pole is in 24 hours of light. Okay? So then the next question would be, if this is summer in the north, so you can't just label it summer. You have to say which hemisphere you're talking about. When it's summer in the northern hemisphere, it's winter in the southern hemisphere. So then, which way is spring? Well, you know what? Usually they make it go counterclockwise, but if you put arrows and label it, so if this was summer in the north, whoops, then this would be fall, and this would be winter, and then this would be spring. Yes, after summer comes fall. And the other thing, guys, so the trick is knowing, and you need to do this, you can use the textbook, but in the lab, what you're going to do, you've got the light bulb and the earths in the back to practice the lab, but you need to be able to draw this picture. And no matter which way, I guarantee you on the quizzes, on the tests, I will not always put summer on the left. You cannot just remember summer goes on the left. You have to look at the picture. But the good thing is that if you think about it logically, you can easily figure it out. So the other thing you need to know is these words. So the Earth, of course, takes 1 year to travel around the sun. So in 1 year, we have 4 seasons based on those 4 positions that we just talked about. The 4 positions are very different in terms of sunlight, and so we give them names. And these names are based on when people first were farming. There's a lot of evidence that the people have always watched the sun, so they knew when the summer was, when it's time to plant, when the winter's coming, and that sort of thing. So first we have the solstice. Solstice means sun stops. Sun stops. So the solstice is, so the winter solstice, which we just had in December, is the longest night and the shortest day. And so for us, the Earth is at its greatest tilt. We have the longest hours of night, and the sun is at its furthest north position in the sky. And then the summer solstice is the opposite. It's the longest day, and that's where we have the longest day in June, and the sun is closest to the equator for us. Then, in between, marking in the beginning of spring and fall, are the equinox. Equa means equal, nox means night, and so in the spring and fall equinox, the hours of daylight and night are very similar. And it depends on where you are. Obviously, if you are at the pole, at the North Pole, if you are above the Arctic Circle, what you see there is 24 hours of night. If you are, or 24 hours of light. So that's the main thing for today. When you draw your picture in the lab, you start with this. You have to show the axis of rotation and the equator. Because if you just have circles, that's not really telling me anything. And finally, I have several links to animations, and I'll put these links on Edmodo so you can look at them.